Hello, welcome today. We have the pleasure to welcome ESA, European Space Agency Director General, Dr. Josef Aschbacher. Also today with us, we have Johan Richard from the Swiss Space Office. He's the Head of Promotion, Activities, Economy, and Science. And well, we have the student teams who will be presenting their projects. And then we'll have a short discussion between ESA Director General and Swiss Space Office and the student teams. So we hope you enjoy this show. And let's start first by saying what is IGLUNA and why we're here today. So we're here at the IGLUNA Field Campaign, and this is the third edition of the IGLUNA that we are running as part of the ESA Lab at Initiative. This ESA Lab initiative is created by ESA to have an innovation hub to mobilize actors and to bridge the gap between academia and industry, while at the same time training the next generation of space experts. IGLUNA is coordinated by Space Innovation. We are a Swiss entity based at EPFL in Lausanne and ETH in Zurich. And well, so far we had over 540 students joining in the 3 editions of IGLUNA, and they come from more than 20 universities around the world. To give you a bit of history, how it started back in 2018, it was the first IGLUNA, and that's how the name came. It was a lunar igloo. So the topic of the challenge was habitat on ice. And back there, we went to Zermatt for the field campaign. We were hosted at the Klein Matterhorn inside the Glacier Paradise and also downtown at an art gallery. Then we moved forward and we also raised the bar for the challenge. So the topic of the habitat remained, but then we put the remote operations as a more difficult challenge to increase the level of the technologies developed by the students. So last year, that was a challenge, and we were supposed to be here in Lucerne, where we are now, but unfortunately we had the COVID crisis and we had to do everything online, which was actually a positive experience because we did a virtual field campaign, and with that, everyone around the world could watch and learn about the student projects. This year, as the situation has been improving and the measurements have relaxed, we decided to do a hybrid campaign. So we are here in Lucerne at the Verkehrshaus, the Swiss Museum of Transport, and also at Mount Pilatus on the top, at Kulm and at Klinserek with the 10th bed, where students place their technology and control them from the museum. And we also have students staying at home because of travel regulations and safety issues. Some teams are coming here. We have 8 teams joining physically and 4 teams joining online. We have project shows, so everything's available online. We have tests. We have also different ceremonies during these 10 days of field campaign. So we will also like to mention about IGLUNA, that how it works. So we have different topics coming together. As you will learn today, we have projects coming from the life support domain. So student teams developing plant systems so we can have food. We have also oxygen and water production. We have architects also taking care of conception and structure, building the habitat, but also the materials with engineers. They do in situ resource utilization so we can actually build everything we would need on the moon. We have teams focusing on navigation and communication, robots, drones, as well as a helmet for extravehicular activities, and of course the power management. So how it runs with IGLUNA, it's a 1-year academic year actually project. So we start in September, we finish in July. In September, we start with a kickoff event where students get to know each other, their projects, and find common interfaces so that they can work together throughout the year. Then we have an expert panel that joins for different reviews. These are the milestones, and they are based on systems engineering best practices. We have the preliminary design review, the critical design review, and the readiness review. Towards the middle, we have the midterm event to also clear all the interfaces and prepare for field campaign. So this year we have 12 teams coming, 9 countries with one common goal, to test their technologies during the field campaign. The topic of the challenge is for these technologies to enable life in an extreme environment, such as space, particularly the moon, but we also focus on the sustainability aspect here on Earth. So now it's my pleasure to introduce you to Johan Richard from the Swiss Space Office, who will be giving a welcoming speech today to our participants. Welcome, Johan. Thank you for joining us.
Thank you, Tatiana. Good morning, everybody. Thank you for having me today, and it's a pleasure for me to be welcoming you. As Tatiana already said, I'm part of the team at the Swiss Space Office, which is part of the Federal Ministry for Education and Innovation and Economy, and I'm leading a team dealing with promotion activities, economy and science at the Swiss Space Office. I would also like to greet you on behalf of our head of delegation, who unfortunately cannot make it today. We are indeed very much looking forward to the field campaign. I think it's a very nice end result of a lot of work, of a lot of labor you've put all into your IGLUNA projects. And I had the pleasure actually to be present in Lucerne on Friday at the opening ceremony, and had also a chance to discuss with a few student teams their approach, the interesting learnings they had from their IGLUNA projects. And I must say, I'm really impressed by the quality of the work, by the passion, and also the diversity of the projects. But also, I think what impressed me a lot is how well they managed to, many of the teams managed to reach out to partners, to industry, to integrate them into their project, to learn from them, and to make their projects better through that. So sorry, was I on mute? No. Good. Is it okay? Okay, very good, very good. So I think for us now, Igloona, which is has been run the third time by the team of Tatiana and Space Innovation, is a very impressive collaborative project, and I think it's really nice to see all the project teams that have decided to participate, sometimes really in their spare time with little or with little support or with little time available. So it's even more impressive. And we think ESA Lab and the IGLUNA project is a very important element actually of our approach in Switzerland, and hopefully beyond, to diversify and strengthen the overall space ecosystem in Europe. And we are happy that we can help build up capabilities which maybe in 5-10 years will hit the road and lead to commercialized, to companies, to startups. We've had one in the past. I hope to see many more from the IGLUNA projects. And so I'm really looking forward also now to your presentations and to see what you came up and what challenges you overcome and overcame in your IGLUNA projects. And I'm looking forward, of course, also to discuss with the Director General of ESA, who we're very glad to have here today, your projects, and ask you some questions. So thank you very much, Tatiana. Thank you much, everybody, for being here, especially also from California, if I understood correctly. And I'm looking forward to presentations.
Thank you very much, Johan. Actually, it's from Canada. So we have our Canadian team joining. And yeah, they're waking up in the middle of the night. So thank you for that. It's part of the ESA member states, so we're very happy to have them on board. And thank you for your nice words and for your support throughout these 3 editions of IGLUNA. So now it's my pleasure to welcome Josef Aschbacher, Director General of ESA. Thank you for joining us today. We look forward to your presentation.
No, thank you from my side, Tatiana. Also, welcome to all of you. I'm always happy to see enthusiastic young people working on space and having crazy ideas, having wild ideas, and making them realize. So it's always really great to see you. And this ESA Lab is a fantastic opportunity to really realize some of these dreams. Welcome to Johan, our friend and colleague from the Swiss Space Office. We work very well and very closely together with the Swiss delegation, as everyone knows, and I'm very happy to see you also here. I do have a few slides, and if somebody could display them, I go through them. I don't want to spend too much on slides because the main time should be used for discussion and some feedback. But if you could load the slides, please, I just update you on some of the elements on ESA that are relevant for the ESA labs. Okay, so I see the first slide. So this is the cover slide. So if you could go to the next one, please, which shows in one slide what ESA is and how ESA works and what the main activities are. Everyone knows us very well, but just to recall some of the key facts and figures. We have 22 member states. Switzerland is a very good, a very proud member of ESA, but also we have many other member states being members of ESA. We are not having exactly the same membership as the ones of the European Union. You know, the EU has 27 member states. We have 22. Switzerland is one of the member states that is not in the EU but in ESA, but also some other member states like the UK or Norway are ESA member states and not in the EU, and vice versa. There are some EU member states not in ESA. These are mostly the smaller ones in Eastern and Southern Europe, which are not yet a member of ESA. Some of them are cooperative members or associate members and are about to join. Our budget is about 6.5 billion per year, which may sound a large figure, but if you compare it first of the amount of money per European citizen, you see here the figure of 12 euros are spent by every European citizen per year on ESA, which is really a negligible amount. It's the money of a cinema ticket or a drink outside or whatever you compare it with. But also if you compare it internationally, it is actually quite modest. And this is something that is of concern to some people because Europe has excellent capabilities, a lot of interested works and projects, very enthusiastic engineers, scientists working in space, but not the same means as, for example, the United States in supporting some of these ideas. And this is actually at the heart of my agenda 2025 to really raise the profile of space and make politicians realize what excellence they have at their disposal, but also see how they can strengthen even further with a new ambition in space this excellence which we have across Europe. We have in ESA about 5,500 people working on site, and of course many thousands or tens of thousands outside ESA through contracts and arrangements which we have. Actually, ESA lab people, you're not getting huge amounts of money from us, but you are still very closely working with our activities, and the network of ESA with industry, through institutions, with students is quite vast and is really important. If we go to the next slide, you will see some of the activities that ESA is doing. I'm not going into all these boxes in detail, but just to say that ESA is active in all domains of space, going from space science to explore the universe and other planets, having astronauts towards applications which are Earth observation, navigation, and satellite communications, over to security and safety, where we use space assets to ensure security on ground and also use space assets to secure safety in space by monitoring debris and making sure that our spacecraft are safe. And also in the last box you see our rocket program, the Ariane program and the Vega program, which are quite unique and quite well working, then operations and technology support across various domains. So this is really showing that we are active in all domains. We are one of the few space agencies who is doing that. Some other international global space agencies are doing one or the other or several domains, but not all of them are doing everything. Then the next slide shows you the agenda 2025, and this is really an activity which I launched when I became DG of ESA. I became DG of ESA on the 1st of March. And on the first day, I put a document on the table called Agenda 2025 in a draft form, which of course was elaborated by with a team in-house, but with my member states, with industry, with the European Commission, to really reflect of where ESA or where space wants to be in Europe medium to long term. And if you want to invest in space programs, of course, you have to have a longer term view, which means that you should really look into the next decade and reflect on where ESA and Europe wants to be in space in 10, 15 years from today. And then in order to realize those ambitions, of course, you need to step back and start today on implementing some of these activities. And these are the priorities that have been defined with a long-term vision in mind, but then what is needed immediately in order to get there. And you see here on the right-hand side the 5 priorities that have been identified. First and foremost, to make sure that in Europe our forces are well combined, and the European Commission and ESA are working well together in spending money allocated to space and implementing space programs. And this certainly is a top priority, which is extremely important, but you may consider this a bit of an in-house activity that is needed, but certainly very, very important. Then you see commercialization, of course, an activity that you see and hear every day now in the news with 3 of the richest people in the world investing in space, Jeff Bezos, Elon Musk, and Richard Branson, but also many, many other companies are developing commercially products and infrastructure that used to be done by public entities. Silicon Valley has been investing or providing funds for many, many companies and building up new startups to develop constellations, data analysis companies, and similar activities. So really, there's a huge activity going on, funded with venture capital and creating a lot of interesting startups and companies. And that's something that happens. And I certainly want that Europe is not left behind, the opposite, that Europe is making good use of its expertise. And we as ESA want to help these young companies and startups to develop and realize their ideas. Then safety and security. As already mentioned a bit before, safety in space and security on the ground. And I really want to explore further what can be done and what projects and activities can be initiated. Of course, these are partially newer domains where ESA is working, but I think the potential is huge. Of course, we do this with member states and the various actors in this domain to make sure that whatever we do is complementary and is serving the interests of our member states. Then you see program challenges. These are some of the programmatic challenges we have across the different ESA programs. I mentioned launcher as one of them. Everyone agrees that access to space is extremely crucial, but also we need to make sure that our launchers are competitive. And you see in the news every single day about Elon Musk or another commercial launcher company launching a satellite or launching astronauts and through a commercially driven program. And the question is, what does Europe want to do to make sure that on one side we have guaranteed access to space? That means making sure that our satellites can be brought to space. On the other side, also making sure that we have a competitive landscape where private companies can also develop new launchers and offer them on the market, and they are part of our ecosystem that is being developed. Another program challenge would be secure connectivity, which is now being discussed a lot, and where also together with the Commission we are discussing how and what ESA will be doing, and this is certainly something of interest to many in Europe citizens, but also industry in implementing programs. Then in Earth observation, you have other challenges like digital twin Earth and so on. So every domain, every program has its own challenges, and of course they need to be addressed thoroughly in order for Europe to stay ahead of the race. And then the last point is ESA transformation. This is more an internal activity to make sure that ESA as an organization is dynamic, is responsive, is quick in order to interact with the new space world, but also making sure that the various ambitions of the member states are met. One big topic within the transformation process is, of course, making use of the ESA retirement wave, which we have. A lot of people are going in pension, and making sure that when we hire new people, that we do hire, first of all, those expertises that are future oriented, but also in terms of ESA staff, that we make sure we have a good spread of diversity and inclusiveness of different of gender, of course, but also different races, ethnic origins, and so on, and making sure that we offer good working conditions to our people. The next slide shows a little bit the link of the ESA labs to some of the other innovation chain activities. So you see on the left side, really the ESA lab network, where we are working with universities, with research institutions, and building up basic and applied research activities. A lot of ideas are being created and supported through this ESA lab activity. But then if you go further towards the right-hand side, you are going towards projects and companies. We have one program called the PhiLab network. PhiLabs are an activity which, in fact, I started 3 years ago here in Frascati in Esrin, where I'm sitting right now. Normally I'm sitting in Paris, but today I'm here in Frascati. And there we installed a PhiLab, which is really, I call it a center for disruptive innovation, where a lot of students and ideas are coming and going, realizing and materializing some of these ideas together with a few senior people and creating new disruptive innovation products. One example was a PhiSat, which is a satellite that has an AI chip on board for the first time ever in Earth observation to do machine learning in space. This technology is now tested successfully and will in the future fly on larger spacecraft. So this is a very interactive system to really bring ideas to life and make them realized. And then we have the Business Incubation Center on the right-hand side, which goes more towards commercialization, where companies are supported to build up a product and really become successful on the market. So you see that the good ideas quite often start on the left-hand side in the ESA lab and then go all the way towards a commercial product, a commercial company that we also support through our ESA activities. We go to the next slide. We go to the ESA lab network. We have 26 ESA labs active today throughout Europe. IGLUNA is a highlight and is the one we discussed today a bit more in detail, but it's really all of these networks are to link institutional activities of the ones of ESA, for example, with university, with students, and making sure that this link is supported and different activities are implemented. I've just heard about your field experiment, about your meetings you have, which is very exciting. And this is exactly the type of activities which we are supporting through this ESA Lab network. If you go to the next slide, that goes a bit towards some of the points to being addressed, since IGLUNA is having Luna in your acronym, is looking at exploration. What you see here is our exploration roadmap, or our long-term planning for activities. We call it Terre Nove, new lands, which we want to explore in the next decade. And you see really from that in the past, we used to be a smaller partner in a larger undertaking. In this decade, ESA is becoming, through its investments and cooperation agreements, a big partner in, or a very essential partner in some of the international activities. In ExoMars, for example, we do this together with Russia. In Mars Sample Return, we have a big cooperation plan with NASA. Of course, Orion, the European service module, is an essential part for the Artemis and Gateway program of NASA. On the ISS, again, we are playing a very important role with our astronaut support in an international setting. And in the next decade, you see here from 2030 onwards, the discussion really is that Europe should and wants to show more identity, more autonomy through its own investments, really gearing up all the expertise that has been created over the last decades, and have a bit more European flags attached to some of the activities and leadership in some of the exploration activities. And there are several candidates and activities which we are discussing right now. Of course, this is early days for many of those, but we have a very clear roadmap in order to discuss and agree on future projects, of course, always with our delegations, because we propose some activities to delegations, but it's always delegations who shape our programs and at the end fund them at the ministerial conferences. We have a big ministerial conference coming up next year, which certainly will see the next set of programs and activities we are proposing. And then we go to the last slide, which is only to conclude and really thank you for this opportunity. I'm really excited to see you, to talk to you, and interact with you, because this is exactly what we should do to stimulate, get young people on board, because you are the future. I know you have heard it many times, but in space, this is particularly important, since many of our activities have a 10 or 20 years lifetime until they fully materialize. And this is something where you are in the starting block to help making them create. So thank you for your attention.
Thank you very much, Joseph. This was a great presentation. It was a very nice overview, and we're happy to see ESA Labs there in the roadmap and how IGLUNA is well positioned. We actually even see some similarities with the field labs, because we do push student technologies for commercial applications. We had a successful team from last year, which were incubated at the ESA BIC, and now they finished their year. And now they are really a founded, well-established startup company, and we really push students to push their technologies, hopefully to see them one day on the moon, at Mars, and beyond. And it's also exciting to learn about Terrae Novae, so how ESA cares about space exploration and the future missions that are planned. So yes, hopefully we'll see some of these student technologies moving forward to the moon and beyond. So now it's my pleasure for the students to give the floor to the students so that they can present their projects. Some student teams are here at the Verkehrshaus, the Swiss Museum of Transport. Some are at Pilatus, some are at home. So you will see a bit of a mix from all of them. They come from different countries. They're working on different topics, very interdisciplinary, but all very interesting. So let's start with the first project, P1. If you would like to start, and we will show also your slides from our side here.
Thank you, Tatiana. So we are team P01 coming from EPFL in Switzerland, in Lausanne. We are around 43 students that have been working the whole year for our project. It's a multidisciplinary project that aims to grow, harvest, and possibly pollinate vegetables in a 100% autonomous way for extreme environments. So we use aeroponics, so soilless culture, to grow the vegetables, and robotic actions to move the vegetables, harvest them, and we're developing a computer vision-based harvesting pollination system to really work closed loop. We also use human waste nutrient as a fertilizer. We have been testing those nutrients for food consumption to follow the European legislation for vegetables. And we also have a scheduling algorithm who aims to produce fresh and different vegetables every day for astronauts or people on Earth to have diversity in the vegetables every day. As I said, our system takes care of the vegetable through the whole life cycle. So planning when to see the new plant, then schedule it, grow it, harvest it, and we're developing the pollination to close the loop. We are an interdisciplinary team with state-of-the-art engineers in robotics, machine learning, computer vision, mechanical engineering. Our prototype is situated on top of the Pilatus, where we are testing every day the different subsystems, one each day, and at the end of the campaign, we'll test remotely all the subsystem and the autonomous system. So we are also located in the control room at the exhibition, where we'll test all the systems. Thank you for listening, and I'll pass the mic to the next team.
Thank you, Aurelien. Hello, everyone. I'm Riccardo Estivalessi, and I represent Lucerne, a group of 20 people coming mainly from Sapienza University of Rome, who dedicated this year to move towards a single goal, which is exactly what Lucerne stands for, and that is lunar operative outpost for the production and storage of microgreens. Basically, we know that on the moon, we cannot overly rely on supplies from Earth. Therefore, we decided to find an efficient way to provide humans with protection and fresh food, thanks to our lunar greenhouse. This year, so we worked on some main features, which are a micrometeorite shield for protection, an automatic cultivation system for the creation of fresh food, a bioconversion unit in order to recycle our resources, and all of that is represented in VR. Next slide, please. Can you hear me? Okay, perfect. Thank you. So during this field campaign, we are testing in Italy a full cultivation cycle with the automation system. And we are going to showcase the capabilities of our prototypes during the exhibition at the museum. In fact, we have scheduled some live presentations of our systems, and there we will also respond to any visitors' questions. Today, we have our project show at 2 p.m., and there we will give deeper insight on each section of the project, showcasing also all the possibilities that are given by the VR. Thank you for the attention, and I pass the mic to PO3.
Thank you very much. So as you can see, we're in the mountain. So good morning, everybody. I'm Marco Bermudez from the team PO3. We are a lunar ice extraction and electrolysis, or LUI, and we are from the Technical University of Berlin. So we really chose our name to reflect our goal, which is to demonstrate a semi-autonomous rover to extract ice on the moon and transform it by electrolysis. So this would be an important project in the next 10 years following ESA's roadmap, since future lunar settlements would require crucial supplies, which can be obtained, of course, via in situ resource utilization. So we wanted to bring together both exciting payloads and rovers to provide mobility. So our plan is to harvest these key resources as hydrogen and oxygen by including a solar-powered extraction payload that will provide extracted water from the dark regions of the moon or the lunar south pole to an electrolyzer. Locations such as the Shackleton crater area can provide constant source of solar energy since they are virtually illuminating during the whole year. Team LUI's plan during this field campaign is to demonstrate the integration of our payloads in an open environment, as you can see now. On the 22nd, we'll have a presentation with polling for participants at home, and for the general public, we are at the Verkehrs House, where we have our prototype available. The next phases of our project will oversee the gradual evolution of the payloads, of course, to be deployed in the lunar environment. And to conclude this campaign, we want to bring awareness to the exciting opportunities that will enable future missions to power a lunar habitat. And of course, we want to inspire younger generations to reach for celestial bodies. So thank you very much.
Hello everyone, my name is Konrad Uściło and I represent Sample 2 project from Warsaw University of Technology. Our main goal is to make lunar soil cement fertile. We want to achieve this by altering physical and chemical properties of this regolith by utilizing microorganisms and organic matter. This technology should enable us to reduce the amount of resources needed to be brought from Earth during manned missions on the Moon. For food supply, it could also solve modern problems with food plantation because we can modify structure of Earth's soil to be more efficient. Next slide, please. During our field campaign at Mount Pilatus, we also present you our second mission. It consists of an autonomous module, remotely controllable, capable of sustaining plant growth using our terraformed soil. The module is sealed, which makes it functional in space condition and also prevents any type of contamination hazards. At the exhibition, we display our samples of different stages of terraformation, and also we show strains of microbes, which are key to our biotechnology experiment. Thank you for your attention, and I bring my next team.
Hello, everyone. My name is Juan Carlos Araña Romero. I'm the team leader of XT Space, the project with a technology for the production of high-performance materials from locally available resources, in this case, lunar rock. The transfer of payloads into space, for example, for research missions, or the construction and supply of manned lunar stations, posing many economic challenges, in addition to technologically complex tasks, with cost for payload transfer of 1.1 million euros per kilogram to the lunar surface and space project requiring large freight volumes, weight reduction seems to be essential. However, raw materials from the Moon or Mars in the form of regolith are suitable for producing habitat-building materials and thus reducing freight costs for further missions into space. For this purpose, continuous mineral fibers, that is basaltic glass fibers, can be utilized in situ to produce fiber composites, as well as thermal insulation, filters, and hydroponic mineral wool for plant cultivation, among other things. However, this requires a spinning machine that can be operated under space conditions. Due to the limited space available within the space elements, like rockets, the system for the spinning technology must be miniaturized. Therefore, the goal of this project is the development, design, and construction of a miniaturized spinning machine for the production of glass fibers under vacuum conditions. Next slide, please. For the field campaign of the IGLUNA program, our system will serve as a proof of concept of this spinning technology as part of the Moonfire project. Therefore, we will validate the current operation of the system under different environmental conditions, as well as various parameters on of the manufacturing process. All visitors to your museum exhibition will be very satisfied, as we will have team members who can answer all their questions in details, as well as infographics of our project. And if that is not enough, we will have also exhibit prototypes of the project, a mini satellite where project will go into space, and fibers produced from moon rock simulant. Thank you very much, and see you soon.
Hello, everyone. My name is Camelia, and I'm presenting the Team P06, the Inflatable Habitat. We are students from the University of Technology in Brandenburg, Germany, and we are developing the prototype for the habitat for the moon. This lunar habitat technology that we are working on is lightweight and flexible, stable, and it's an inflatable dome structure that offers space for experiments and accommodation. And it's designed to be used on the moon or in extreme environment on Earth. It's made out of modules with very similar dimensions, which makes it very easily expandable or exchangeable. And with those different modules, it can be easily expanded into a village or a bigger habitat with more rooms. We made this concept for easily transportable habitat because we think that the scientists should not be fixed on their location when they're discovering remote location. And with this possibility of assembling, disassembling, and easily transporting their own laboratory, we believe that scientists will have will be more autonomous and will be kept safe while having their equipment even in distant locations. Next slide, yeah, thank you. We are still working on developing the prototype, and we are exploring its advantages and disadvantages in order to learn from it and optimize further. We had a very tough way to Lucerne. It was full of certainties and challenges. And one of them was, for example, that we've never met in the same room, and we are only 7 members, but we haven't met each other. We still succeeded to produce a simplified prototype, which is in 1:1 scale. And we are currently presenting it in the field campaign in the museum, the Verkehrshaus in Lucerne. By presenting it, we are meeting some everyday challenges, and now we're learning how to check for leaks, and we're thinking of how to optimize this process, for example. But we are also very excited to see people's reaction, and we are very happy to have the chance to raise some interest in space travel, space architecture, and we also are very happy to let the visitors inside and to see how they react to the space we created. Thank you very much.
Okay, hi, I'm Jasmine Rimani, the project manager of the Corodro team from ESA Super France. Corodro stands for Collaborative Rover and Drone, and as the name may suggest, we have a rover and a drone. It moves in a known environment. To be more precise, the drone simulates the operation of a lunar trusted boat, and in general, we are interested in the collaboration between systems with quite different characteristics and mobility. So the two systems work together to map and explore this unknown environment, and our objective is literally to develop and test algorithms for autonomous operations and navigation, and therefore push forward lunar and space exploration. Next slide, please. So during the IGLUNA campaign, we developed different algorithms for mapping, so SLAM algorithms, path planning to move the system totally autonomously, and task planning to give some decision aid to the different systems. We test everything in France during our virtual field campaign, and both systems reacted quite well. We were able to map the environment, recognize point of interest, give all this information to the rover that's made a plan for both himself and the drone to go again to the point of interest and do some science and communicate with an operator that was in a control center. Our results have been displayed yesterday during the project show of Corodro, and so if you want to know more, please watch our video. Thank you.
Hello everyone, our project is called LIGHT, Lunar Navigation Helmet, and we're a team of 10 students from the Aristotle University of Thessaloniki. We're aiming to build a general tool for astronauts' navigation and assistance on lunar exploration missions, real or analog. Our primary motivation were three key issues that astronauts face in the completion of mission-related tasks. First of all, the complex, cognitively demanding nature of the task requires a high level of training. Secondly, the special awareness and navigation of the astronaut must be constantly supported by communication with the base. And finally, factors such as the difficulty of moving with a suit, fatigue, stress, strict operational procedures provide little time for free exploration and scientific fieldwork. To that end, we're hoping to set up a proof of concept system that alleviates the above limitations by utilizing augmented reality technologies. The system consists of two basic subsystems, the AR software and the weather station sensing the environment. In the light helmet, a graphical user interface structures the experience of the astronaut and provides visual tools to help with real-time navigation, visual sequences to help with the repair of a weather station, and a visual display of his biometric data and the conditions of the environment. The weather station will collect the data and streams it in real time. Next slide, please. Unfortunately, we weren't able to participate in the physical field campaign, but we wanted to approximate the conditions of the lunar environment as well as create an experience similar to the experience of the visitor in the field campaign. So we went to abandoned mine near Thessaloniki and we shot a demo that we will present at 4 p.m. today, and I hope you enjoy it. Thank you very much.
Hello, everyone. I'm Jillian Odebear from Lunar Zebro. To push the boundaries of autonomous swarm robots, that's our overall goal at the Zebro Group at the Delft University of Technology. The Zebro Group builds unique robots, each equipped with 6 C-shaped legs instead of wheels. Our group's latest endeavor is building the Lunar Zebro, which is the world's smallest and lightest lunar rover yet, and sending a single one to the moon to demonstrate our technologies. However, we envision an entire swarm of Zebros on the moon one day. We aim to answer one fundamental question in space robotics. Can a swarm of smaller and simpler rovers be more reliable and robust as compared to a single large, expensive, and complex rover? We believe that this way missions can be carried out in a more time and cost-effective manner, risk can be taken without compromising an entire mission, and the applications of swarms are endless, both on other planetary bodies as well as here on Earth. IGLUNA 2021 is our first large-scale step towards realizing such a swarm, providing us with a platform to test our group of Zebros under moonlight conditions. In the past year, our team of 25 members has worked hard on designing and building these autonomous roving robots and planning the entire mission that we will carry out during this field campaign. Next slide, please. This mission entails the group of Zebros safely exploring an unknown area and locating and identifying randomly placed targets while being supported by docking stations to allow for no human intervention needed. The docking stations are also a first for us, allowing the rovers to recharge and also escape unfavorable weather if needed, while also providing the data relay between the rovers and the ground control. Our mission at IGLUNA with these rovers that are similar to the Lunar Zebro itself provide us with invaluable experience towards our future moon missions. To learn more about our systems and our tests on Mount Pilatus, we welcome you to our online project show, which is on July 22nd. And if you are in Lucerne, please come and visit us at our exhibition booth at the Verkeershaus and also at the test bed on the Krinsereg. And be sure to follow us online on our journey to the moon. Thank you.
Bonjour, hello, and grüezi from Team MIST Lab. at Polytechnique Montreal. My name is Marcel Kaufmann. I'm speaking to you from California this morning. Our goal at MISLab is to develop a self-organized team of robots that would explore and map planetary environments that are unknown a priori. Why do we want to do this? We want to break the one rover, one mission paradigm, and we envision to have collaborative missions with human-in-the-loop supervision. For instance, an astronaut on the moon exploring together with a team of robots, or even a remote operator like in the IGLUNA scenario, controlling a team of robots on the moon or Mars. How do we do this? We have 3 robots deployed for this field campaign. They're equipped with heterogeneous set of sensors collecting valuable data about the terrains. And we also collect data about the human cognition metrics using EEG, heart rate variability, and skin conductance. Next slide, please. Our field test, unfortunately, can't take in Switzerland, but we took our robots to the Mars analog terrain at the Canadian Space Agency, and were able to rove around in such challenging terrain there. Our control center was located 17 kilometers away at Polytechnique Montréal, where the supervisor of this robotic system was able to dial in to the field exploration via virtual reality. In virtual reality, we're able to direct the rovers to points of interest, while the terrain data and areas of interest are communicated back. The project show that we are showing and where we're taking you virtually to the Canadian Space Agency field will be taking place tomorrow. And we are very happy to be part of IGLUNA 2021. Thank you.
Hello, my name is Michael Ebnicher and I'm the project leader of Project Rebels from the Technical University of Munich. We want to show the feasibility of combining solar sintering with a mobile robot platform. We think this greatly simplifies the construction of very remote infrastructure, as we are only dependent on 2 resources that are local, namely the sand and the sunlight. For the IGLUNA field campaign, we have developed the first iteration of our rover, which can hold the big Fresnel lens, can track the sun, and can actually move the Fresnel lens around. Next slide, please. The IGLUNA field campaign is especially important to us because we can test and validate our system in the environment we have developed it for. And today we are very lucky because it is actually the first day with a lot of sunlight. And so my team is currently up the mountain and is validating the solar sintering, checking if it behaves the same as it did back in Munich. And from tomorrow on, we will then conduct all the tests that we would like to conduct in order to know more about how actually our system behaves. Thank you.
Hi, Power Hub could not join us today, so I will be presenting on their behalf. This team is a group of motivated PhD and master students. They are from the University of Strathclyde, and they work toward creating a complete power system for long-term space missions, consisting of a mix of solar, thermal, dynamic, or space-based energy harvesting concepts. So what they want to do is to demonstrate lunar habitat powers generation and storage methods, because wireless powers transmission, fuel cells, and nuclear fission for lunar applications. So that's their main objective, and they plan to do this with physical prototypes and computer simulations to showcase that technology. So this is one of the teams that had to stay home due to the corona situation, but they were able to finish successfully their project, and they demonstrated the viability of the hydrogen fuel cell and wireless power transmission prototypes, also reliable and resilient power generation. They also worked on the concept of solar power satellites and nuclear technologies. And in their project show, which was already the first project show we had on Saturday, so it's also available YouTube here in our channel. You can rewatch it if you haven't done it. In their show, they provided novel insights into how power can be generated and stored for a lunar base. So that was all the student teams that participated this year in IGLUNA, and now we have almost 10 minutes, a bit more maybe, to discuss together. some feedback perhaps. So let's start with a round of feedback, perhaps first with ESA Director General, if you have some general inputs for the students or some questions you would like to ask them.
Yeah. No, first of all, I'm really fascinated to see what you do. It's really amazing. You have so many ideas and brilliant ideas, and I wish to see many of those come through, all of them, because I think they're worth considering. What I really like is, and some of you have said it in your proposals, your approach of having smaller, say, rovers, for example, on the moon, rather than one mission, one robot, or one mission, one rover approaches. And I think this is showing that that you, on one side, go for a complete new space approach. That means you are looking into miniaturization of technology and therefore making it much cheaper. But also there's an issue of reliability, as you perfectly understand, that when many small robots, of course, have a high reliability, they may not have exactly the same performance or the same instrumentation as the big ones. I mean, the physics, the laws of physics apply to old space and new space at the same time. So you cannot say I'm new space and therefore I can break the boundaries of physics. Of course, they also apply. But still, you can do a lot with these smaller constellations or smaller, in this case, robots. So I'm really fascinated by your approach and by your ideas. My question is a bit, how do you have a way forward on realizing those into projects, companies, startups, or to really make them happen and get access to funding? Or what is your plans? What are your bottlenecks? And do you have any suggestions of how ESA could help you along this way?
Very good question. Is someone here wanting to answer that?
I can answer that from P10. So P10 is tapping actually into some funding from the Canadian Space Agency with the FAST grant initiative at the moment. And we are also planning and taking part in the Pangea mission with ESA this November. So the project that we are working on with IGLUNA, we also have partners from ETS, another university in Montreal, and we develop also another type of robot, which are actually ball-shaped spheres, specifically for the moon. And we would like to see swarms of robots to explore the moon, and especially for the points that you mentioned with resiliency and yeah, cost reduction, mass reduction. Yeah, it's very exciting.
And how is your road towards making it happen, either through a commercial company or through other funding? Are you succeeding, or are you stuck somewhere? And if you are stuck, is there anything ESA could do to help?
So ESA could probably help in hiring us after, and so that we can transfer some technology there. Our team specifically consists of PhD students that seek to work in either academia or industry after. Personally, I also applied for the astronaut position this year.
Great.
So I would like to bring it to the moon if ESA can develop it. We can develop it together. That would be great.
Okay, now great to hear that we have an astronaut candidate, probably some more of you in this list. That this is, as you have seen, there's a huge interest. People are really thrilled by the opportunity. We got more than 22,000 applications, which is just amazing, and I'm very happy to see such a huge interest. But yes, we are looking for clever people. As I mentioned before, in the next we're having a retirement wave ahead of us. That means in the next 5 years, we are losing in pension about 500 people. That means we need to replace at least 500 people in the next couple of years. So there's huge opportunities coming up. And one thing I put a huge emphasis on through our HR program is to make sure we get new ideas into ESA and new people, new ideas, and your network are the perfect boundary conditions or starting point in order to do that. So I can only encourage you, push your your borders and look at our websites. All our positions are published on our website, and apply and make contacts with people and make sure that, that there are lots of applications. I can only encourage you. I'm very happy to see this enthusiasm and these young, the young people finding ideas and projects and see how they can be materialized. So really fantastic, yeah.
Thank you very much for your kind comments, Dr. Aschbacher. So yes, that's what we try to do with IGLUNA, to inspire the students so that they become space experts and then they go and realize their projects as well. And well, I would like also to give the word now to Johan Richard from the Swiss Space Office, if you have a general feedback or some questions as well for the student teams.
Yeah, thank you, Tatiana. So first of all, let me join Josef in congratulating the teams. As I said, I had a glimpse on Friday in some of them in Lucerne, and the presentations today have only supported my first impression of very dedicated teams. So I have, I think I joined actually Josef in the excitement about the small connected swarms. I think this is a very interesting development, and it will be very interesting to see for us as well how this develops. But and of course also the question, what are the next steps, is I think if there are other teams who want to chime in, I'll be more than happy to hear that. But I have two specific questions. The first is, does any one of the teams want to share their biggest learning as a team in the project? I think this is also interesting for us. I have already asked this question to Theo Delft, so I'm sorry guys, you would have the answer yet, but maybe there's another team who wants to chime in. And then I have a specific question for the PO6, so the habitat. Did you already look into how this habitat will behave under vacuum conditions? Because right now I understand you have a prototype, and is that something you plan or you did already? And what are some learnings there? And the second question I have, a very specific one, is for PO9. So for the docking stations, I understand from your presentation in Lucerne, you did that in a topology optimized way. And I wanted to understand, what exactly did you optimize for in that optimization?
Okay, let's start then backwards, I guess. First with P9, are you ready with the answer?
I think he said that he had already asked us that question and was proposing it to the other teams. But I can weigh in on how we are working towards realizing our project and our goal of reaching the moon. Our philosophy at TU Delft that we've also followed with, for example, the Delphi C3 CubeSat that we launched back in 2006, is to really build the hardware and show that it's ready to go. And that's what we're doing with the Lunar Zebra as well. So we've already made one engineering model, and we're working on the second one that will go through a range of environmental tests to show that it can survive the conditions for the journey to the moon and on the moon. And how we actually achieve this is also through a lot of our partners that provide us with in-kind sponsorship for the hardware, for example, but also advice on how to actually realize this and work together as a group. So it's really nice to hear that you support our ideas as well, because that is the way that ESA could actually help, is by believing in our concept, because as you said, it's quite different than what we've seen till now. So yeah, thank you.
Yes, thank you, Julian. The question actually for you was on the topology optimization. So what exactly was optimized there with the docking stations? But really nice answer, thank you.
Okay, the topology optimization was actually for the docking station. So like you said, we created this docking station to kind of house the rovers and protect them from the weather conditions here on the mountain. And the optimization comes in by reducing the material that we need, by only having enough material where the loads actually are carried throughout the structure, and the rest then are to provide the sealing capability. So it also gives it a nice look and very spacey if you want to check it out at the testbed. Thank you.
Thank you very much. Now let's go for P6. You remember your question? Great, thank you.
Can you hear me well? I think I have troubles with the connection. Anyway, thank you for the question. It's exactly the direction that we are aiming to follow of the we've been thinking also about an alternative way. No? I'll come there.
So we have some connection issues, but luckily I'm just beside, so he can speak here.
So thank you again for the question. What I was trying to say is that the future steps of our developing of the projects are concentrating in developing simulations. We wanted to part with some simulation specialists at the university and to try to find out the answer to those questions on how would it behave in how the habitat would behave in a vacuum conditions, or how would it behave also in extreme conditions on Earth with particular tests on the reaction to wind, for example, or earthquake, or whatever else extreme condition we can create. And we were also thinking about alternative ways to fill those inflatable parts by not inflating them, but thinking about some out-of-the-box decisions on that. For example, trying to see if we can use some regolith for to fill the modules and then take profit of the vacuum by creating a shelf with our construction.
Thank you very.
Yeah, thank you very much.
Thank you very much. That was a very good answer, Camilla. So there was the first question again of what was the biggest learning. So P9 already answered. Is there another team that wants to answer? What was your biggest learning in this year's IGLUNA participation?
I could answer it. For us, the biggest thing that we learned was probably how important communication is. And I think Corona actually very accelerated that learning, especially when working on interfaces. Communication is key, and if not everything is properly communicated, you can run into big issues. And yeah, that was probably the biggest learning that we had.
Thank you very much, Michael. So as I don't want to run too much overtime, but perhaps if a student team has a question to ask to ESA Director General or to the Swiss Space Office, is there anyone with a question that you would like to take the opportunity to ask today? Don't be shy, this is your chance. No one has questions?
Is it okay if I ask something?
Yes, we have one.
Okay,
It's
so
more a
we are
general
really
question.
excited.
How does the pandemic have changed space? Does it change it a lot with a different way to work, or is it exactly the same as before?
I can briefly answer on this. Yes, it has changed quite a bit. On one side, we had impacts on some of the developments of satellites and rockets, as you can imagine, because some companies had to partially close during lockdown in March, April, May last year. So yes, there have been some impacts from that point of view. They typically are delays of the satellite development because of workers not being able to be on site. Some of it was recuperated, but in some cases we have actual delays. And then the biggest change certainly is in the workforce in ESA, but also outside in the industries. In ESA, for example, we have discussed right now, or we are discussing right now, the new working conditions after COVID. So in this famous new normal, which will come now or soon after the COVID crisis is over. There will be many changes happening. Certainly, what I want to introduce much larger is the amount of teleworking that people can apply. We have a teleworking scheme in place today already, but I would like to change the rules to really make sure that people can telework from even from their home country so for a certain amount of days per month. But also, even if they are sitting in an ESA establishment, like in Frascati, in ESTEC or ESOC, that there will be a fluctuation of people they're not always on site unless they're really needed to be on site for certain critical tasks where, of course, on-site presence is required. But for the majority, we can arrange a very hybrid system of teleworking and on-site presence. So that's one thing. Second thing certainly is traveling and missions. We used to travel a lot in order to go to conferences and events. For example, you have a hybrid event right here. I would have normally come to see you, but now I'm doing it virtually, which is certainly an element of the future. Of course, a virtual meeting is not the same as a physical meeting. If you see people, if you can exchange a bit on a coffee break and have a few private words, that's always irreplaceable. But on the other side, today I have 6 meetings, and I can be in 6 meetings at the same time and even different continents. So, of course, there are advantages of this nature as well. So as you see, there are pros and cons, but certainly the way how we participate in certain events is changing. Also in view of the environmental protection or the carbon footprint. I have in Agenda 2025 proclaimed that I would like to reduce drastically the carbon footprint of ESA, ourselves as staff and in our buildings, but also through our industry. There's a 46.2% target which I have expressed, which is coherent with the IPCC guidelines. So yes, it will change a lot, and yes, I think people are very adaptive, especially I see the younger generation, which is quite open to shared offices, flexible offices, hot desks, as we call it, which makes interaction easier on one side, also more fluid and more dynamic. And this is certainly a new culture that will come to ESA after the new COVID. I call it after the new COVID. In fact, we're already doing parts of it now, but it will be more formalized as of 1st of September when we consider that we are coming back to the new normal, as I called it before.
Thank you very much. And we have in the meantime another question coming up from Conrad. Would you like to ask your question?
Thank you very much. I would like to ask, how do you see biotechnology on space? Do you have any opinion about utilizing biotechnology on the space missions?
Yeah, I mean, biotechnology is, I would say, a discipline which I consider certainly important and growing in terms of its relevance in the future. We are a bit at the early stages on this research, as you probably know, and I certainly want to explore what are the options and where we can convert them into real projects. So very interested, but we are in early days in our activities. But since I'm speaking, maybe just one last comment on the previous question and the previous comment I made. We are changing the ESA way of working, in particular to make it more attractive for young talents and young people, because I know that you people are very much sought by different companies and organizations, and I would certainly want to make sure that ESA is one of the best places where young people want to work, and that's why I'm really working on working conditions to make them attractive and flexible for the young generation in particular, knowing that you have different needs and different demands than the more older generation, and certainly want to attract young talents, and this is for me very important.
Thank you very much. We have 2 more questions. I am sorry that we are running a bit longer, but the students really want to seize the opportunity. I hope this is fine for you, Dr. Aschbacher and Johan, to stay 5-10 more minutes.
Yeah, I have to leave at 15 latest, but I'm sure we can manage by then because I have another meeting coming up. Yeah?
Yes, now the word to Marco from P3. He also wanted to ask something. Marco, are you there?
Sure. So, like we said, our most important goal is really the coming together without payloads, really get to put them together and have a nice project. However, there's always the human factor is really important. And we know this that there's this para-astronaut feasibility project. So how do you envision this will impact on the upcoming years and the involvement from academia, from the other private sector? We would like to know.
Yeah. Okay. Thanks, Marco. I just saw while you were speaking, there's a cable car going up and down behind you. So you have a very nice working environment. Para-astronauts, very interesting project. You have certainly seen all the announcements of what we do. It is a feasibility study that we are launching. So we have launched a call. We have got applications, about 400, as you have seen. And now we have to see what this really means. Do we need to make adaptations in the space station, for example, to cope with the disability of the candidates? So this is now the work that we start. So we have not yet, we will not yet select an astronaut, because first we really need to see what the implications are of this. But I'm very committed. I want to do it. But it will be, the applications have been submitted at the same time with the other astronauts, but the finding of a para-astronaut itself will take a bit longer because of this feasibility study. We have to do case by case, basically, of the various candidates. But just to summarize, mentally they have to be fully fit, like all the other astronauts, but they have a physical handicap, and this physical handicap we want to be able to compensate or deal with, and this is exactly the study which we are conducting right now.
Thank you very much. Just one last question before you have to go. So Gillian, would you like to ask your question?
Yes, my question is for ESA. I want to know what kinds of moon mission research and testing that you guys are doing right now, and what kind of experts you might have that we could also perhaps tap into and get advice from, and yeah, what kind of testing. For example, we've been to STEC to test our rover in the Mars yard, but perhaps if there's a more lunar environment that we could test in, that would be amazing and help us towards our goal.
Okay. No, thanks, Gillian. Yeah. Thanks for this. I mean, we are having different lunar projects, as you perfectly know, which are in the pipeline. There's one called the Large Lunar Lander, which is, as the name indicates, a large lunar lander. We're also having ideas of smaller competitions. One idea is that we basically offer a launch, and we ask then participants to come with their ideas and propose to us what they can do and how they can be doing it. But we would contribute through a free launch into space. But this would mean a PPP approach, a public-private partnership, where we pay something and the company or the institutions will pay another part. Then this is more the mature end of it. Of course, we participate with NASA and other partners on several activities. And then, of course, we invest a lot in what we call low technical readiness level research, where we investigate, or where we do research on material sciences, on propulsion, on instruments, different instruments, environmental conditions, meaning conditions on the moon, as they are much harsher than on the Earth. So there's a lot, and there's a huge number of individual activities we are conducting there. It would be too long to go into them, but they are usually smaller in terms of scale, sometimes a few 100,000, sometimes even smaller than that, to really test various building blocks for future lunar missions. And this is actually a strength of ESA, that we do invest so much into basic research and technology development. And this is very helpful for companies, startups, then to really take some of these investments and bring them to fruition. That means bring them to a real project. And this is something which we have as a general philosophy. So there are many opportunities. We have programmatic frameworks. We have technological collaborations. One would really need to sit down with the experts in this particular field you are interested and see what the options are. But we have quite a few of them.
Much. So now to wrap up the session, any concluding remarks you would have from your side, Dr. Aschbacher?
On my side, I'm just fascinated by what you do, how enthusiastic and how energetic you are presenting these new ideas, and I really I can only wish you good luck in getting these ideas a step further. And I do hope that some of them I see realized in projects and activities. So first of all, congratulations to all the fantastic work, and I really would like to make sure that ESA helps in making the next steps which you need to do to make this a reality.
That is really kind of you, and we'll take your word for that. So thank you very much for your support. And also, Johan Richard from Swiss Space Office, would you like to end with some concluding remarks?
Thank you, Tatiana. I think everything has almost been said. So I join Josef really in the congratulations. I've said it before. It is impressive. And I'm very sure that we will see a few of the projects go on and pop up somewhere on the horizon in a few years, either in ESA or in the case of the Swiss project somewhere in Switzerland. So I'm really looking forward to that. And I wish you all the best. Good luck and keep on pressing and working as you did in the past year. I think you're set up for a lot of success.
Thank you. We really appreciate it. So thank you everyone for joining today. Thank you, ESA Director General. Thank you, Johan Richard. Thank you to all the students for presenting their experiments, their prototypes today. And thank you to all our viewers as well. So I would like to invite you to our next show happening today at 14 hours Central European time. Like P2 already mentioned, it's their turn. And then at 16 hours, it would be P8 from Greece. Wishing you a very nice rest of the day and hopefully see you in Lucerne around or online if you can keep watching us. And yes, thank you again for this wonderful meeting.
Thank you.
Thank you very much.